So, welcome นะครับ everybody again นะครับ to the King Royally Initiated Laem Phak Bia for Research and Development. And I recap again. So I am also the environmentalist here. So studying my PhD on climatology here at the LUD project. And introducing and going over again. So what the project actually does is with the concern of the rising population from the Phatchaburi province, we have basically indicates that there is a concern for domestic wastewater being water generated from us as humans into the natural reservoirs that is basically declining the water quality of the Phetchaburi River. So therefore His Majesty the King, His Majesty the late King, was concerned with this problem. So therefore he initiated the project here on the 12th of September 1990. So with the project, he basically gave out three ideas. The first one being simple technology. The second one being easy and simple in order to do, which together combines with the cheap and inexpensive technology. And the last one has to be done through the nature by nature process because that pretty much answers them all. And so Professor Kasane came up with four different types of treatment technologies. The first treatment technology consists of 5 consecutive ponds. The first pond, as you can see here on your left-hand side, is the first of the 5 ponds. This is called the sedimentation pond. Basically, water we receive the amount of water per day. We receive around 6,000 cubic meters of wastewater per day, but the maximum capacity of this system is 10,000 cubic meters. So we're going at 60% maximum capacity. So we basically built the project so that the loading for the water is basically higher than the expected value. So we kind of like are prepared for the growing population in the near future, and we're able to predict that through the population trends, this system can take in the entire province until around 2050 before it reaches maximum capacity. So explaining about the sedimentation pond, the depth of the sedimentation pond is 2.5 meters, is the deepest of them all. And the purpose of the sedimentation ponds, as the name states, is used for sedimentation. So inside the wastewater, once transferred from the sewage system of the Phetchaburi Municipal through an 18-kilometer HDPE pipeline to our project, having the retention time of around 7.5 hours in the pipeline. It reaches the sedimentation pond, stays in the sedimentation ponds for around the hydraulic retention time of about 7 to 9 days. So during this time, organic molecules and inorganic molecules, they become attached to each other, then they settle down, as well as depicting some heavy metals and other toxicants, which is quite low due to considering the source of this wastewater is domestic wastewater. We have our bed of the sedimentation pond being covered with clay particles. We know that clays are also negatively charged particles, and these heavy metals or toxicants mostly are found to be positively charged. So therefore, these clays and these sediments, they tend to attract one another. And every 4 to 5 years, we empty out the system, take out the sediments, and again use sediments for other fertilizers, which can again be produced in our agricultural uses as well. The water, after staying in the sedimentation pond for 7 to 9 days, then moves itself through an evaporative flow into the second pond on your right-hand side. The second pond, the third pond, and the fourth pond near your far left all works as one system together. We call this the oxidation pond. I would like everybody to think that in treating wastewater, it's quite simple. It's to provide oxygen to the wastewater, just like in your fish tank where you had to have your aerator to provide the water in the tank to become clean. Treating wastewater sticks to the same principle, so therefore we have to get oxygen through the wastewater. There is 2 processes or 2 mechanisms that pretty much put oxygen into the water. The first mechanism, as you can see with the design of the pond, we're quite open up in the space, so therefore you can feel that the wind basically blows on the evaporation, causes latent heat to be expanding, coming out. So the evaporation, like 583 kilocalories, once evaporate, oxygen molecules then be able to stick themselves into the surface water, and therefore with the evaporation takes away heat, making the top portion of the water becomes cold and dense. So therefore the cold, dense, rich oxygen basically drops down to the lower portion, while at the lower portion there is also anaerobic digestion inside the pond. So therefore the anaerobic digestion causes heat as a byproduct. So therefore they bring the low oxygen up into the surface again. This process is called thermosiphon. The other process of getting oxygen into the wastewater is, as you can see from the color of the wastewater, it is quite green, so therefore there are naturally growing algae. So example of the spirulina species. These algae, they have their chlorophyll, so therefore the ability of the chlorophyll is to photosynthesize, and therefore with the process of photosynthesis, with the sunlight, these chlorophyll are able to produce oxygen to the wastewater. However, the life cycle of these green algae is quite short, 7 to 9 days, and they tend to die out. And this also causes the process of eutrophication. So in order to stop the process of eutrophication or water becoming too rich or with dead plankton or dead phytoplankton, we have to release herbivore fish. The two types of herbivore fish that we release are in Thai called planin jilada, or the other one playi sotet, which is the Nautipia and the bleaker, which are herbivore fish, and they consume these phytoplankton or green algae at different water columns. We have a research that back up this theory. Basically, we have to release around 4 fish per 1 square meter area of the surface water. So therefore, we get this balance in ecosystem. So therefore, part of the CSR activities is we allow different groups to come in and release fish into our project. So if you could hop down, we do have some fish ready as the group will be releasing fish into our third pond here. Okay,ครับ
ใช้แข็งแรงครับไอ้ผมดึงให้ครับ and you free them free them เอาครับ
You can get inside. Yeah, thank you.
let them go
นี่นะ
เอาใครครับไม่ได้หมดครับ
Sorry, I'm in your way. I'll get you out while you're away, sorry.
ไปหนึ่งครับ
Really? Mach schon noch Fotos.
May I take it?
Ja. Wait. Okay.
I did that, right?
So where's the...
If you come down sufficiently, I can photograph you guys. Once again. Can't see myself. Success.
No fish inside? That's perfect.
Yeah.
May I take for you?
先生の研究こんな感じじゃなかったですか。ごめんなさい。なんか環境とか。
Wait.
To the wastewater. These plants, we are known to them to be hyperaccumulator. So we know that inside domestic wastewater, there's a lot of nutrients because again, the source of wastewater actually comes from us. In your detergent, in your cooking, there's a lot of organic matter. So therefore, these trees or Typha augustifolia or rock or different types of grass, they love these organic matters, so they hyperaccumulate and they phytoremeditate. So hyperaccumulate meaning they accumulate the organic matters, and then they phytomeditate. So phyto meaning the plant kind of like. So they photosynthesize. in their leaf and then release oxygen in their roots to give to the wastewater. So they kind of like in medical, they pretty much provide oxygen to the wastewater, so release it in the rhizosphere. And the plot is defined by a 5 meter by 100 meter. The system works by having the wastewater flow into our plots for 5 days. Then we stop the water from coming in for 2 days in order to plant to rest, and therefore we tested out the water quality using the BOD, which is the key indicator of wastewater. BOD stands for biological oxygen demand. So therefore, the Thai government states that the BOD has to be under 20 milligrams per liters in order to pass the governmental standards, and we were able to achieve that with all the techniques. So that was the second technique. Now we moved on to a third technique, which is a smaller plot. So this is very suitable for around a 100 and 200 people community. So this is a 5 meter by 25 meter plot. Again, the species we use is the Typha augustifolia and the rot, which we use, which in Thai explains the ทูบฤาษี and กกกง นะครับ and therefore we release the water into the plot. This time we let the water stays there for 30 centimeters in depth for the entire 7 days, because again, these plants, they're also known for the aquatic plants, so therefore they're able to hyperaccumulate and they photoremeditate, giving oxygen to the wastewater and treating the wastewater and reducing down the BOD loading of the wastewater. So therefore, these water can then be released back into natural reservoirs or again be reused for agricultural purposes as well.